All right, so we're going to multiply everything along the diagonals, add the ones for the first three, subtract the ones for the last three. So here is an example. All right. And all you need really is one example because it's really not complicated at all. So what we're going to do here is we're going to reproduce the first and second columns here. So we have 3 minus 2, 1, 1 minus 1, and 2. Now, I draw my diagonals this way. 1, 2, 3. So your diagonals, they have to be full diagonals. They have to include 3 elements. Okay? And then the other diagonals are here, here, and here. Now what I do is I multiply all the numbers along the diagonal. So for the first diagonal, I have 3 times minus 1 times 5 plus, now I go on to the second diagonal, 1 times 4 times 1 plus 0 times negative 2 times 2. Okay, that was easy. Now, I'm going to subtract all the rest. So a little trick of the trade is first write down that minus sign, then go to your matrix and start multiplying so you don't get confused with the negatives. So minus, now I go here. I have 1 times negative 1 times 0. Minus, go back to your matrix, 2 times 4 times 3. Well, I'm going along the diagonals. Oh, no, it doesn't matter. And then, so it's minus 5, negative 2 times 1. So now, I have here 3 times, negative 3 times 5, negative 15, plus 4, plus 0, minus 0, minus 6 times 3 is, 8 times 3 is 24. And then plus 10. Okay? So the zeros go away. Negative 15 plus 4 is negative 11. Plus 10 is negative 1. And this is negative 25. Yeah. Same. I just subtract minus, minus, minus. The pluses are the first 3 and the minuses are the last 3. So the pluses are the ones that go left to right, and then if you're going the other way. Okay, so the way we write this is either A, like this, determinant is negative 25, or determinant of A is negative 25, and so on. Now, so this is the determinant. For the 2 by 2s, what we were doing is finding the determinant, then rearranging the matrix and so on in order to find the inverse. There's definitely a way that you can do, that you can find inverse of a 3 by 3 manually. However, I've just chosen to not do that. So we're going to find the, what do you call it? Inverse using our calculator. Okay? Calculators. On your calculators, here's what we're going to do. You're going to press second, and here you have a button that says matrix. So second matrix, and you have here matrices.
Whoa!
Now, here's what we're going to do. First, you have to put in your matrix. So you go into the third tab for edit. Enter. Now, here, you want to put in a 3 by 3. So 3, enter, 3, enter. And here you have a 3 by 3 matrix. So you're going to put in the 3 by 3 matrix that's over there. So we have 3, we start going, it goes across. 3, enter, and it goes across to the next entry. 1, enter, 0, enter, -2, -1, 4, 1, 2, 5.
This is incredible.
Okay? You were talking. Second matrix, edit, enter. So now we have our matrix. Second, quit, go to the home screen. Okay? Now, I want to find the inverse. I want to find the inverse of this. So you have to now put in your matrix. So go back to second matrix. Press enter to select matrix A. Now you want to find the inverse. Well, here you have an inverse button. It's the same as the matrix button. Enter. That's the inverse.
Whoa!
However, you will never, ever give me the matrix in decimal form. So press math. The first one says convert to fraction. Enter.
That's really cool.
That's your inverse.
Mind blown.
Okay?
So, can we have
Okay, so that's your inverse. Okay. I will talk about using this on tests later, not right now.
So the actual.
So these two are different. This is part 1. A is finding the determinant. B is the inverse. So for the inverse, you're going to put in this matrix, etc. Okay, now, you can, if you go back to matrix, press the arrow button to go to the math tab. The first one is determinant. If you press enter, okay, and now go second matrix, select matrix A, close the parentheses, enter, that's your determinant.
One more time.
Second matrix,
Second matrix.
second tab is
okay, I see it. Yeah.
the middle, okay, the middle tab, if you just press right arrow one time, is DET determinant.
Yeah.
Enter. Now, you need to put in the matrix. So you do second matrix again to extract the name of the matrix. Select number 1. So just press enter. Close. -25. Now, okay, we'll talk about it later. You will not be able to use your calculator to, for the entirety of the tests. So it is in your interest to know how to find the determinant of a 3 by 3 by hand. I will not ask you to find the inverse of a 3 by 3 by hand, so that you need to use your calculator for. Okay? With that, we're going to move on to section 3.
I have a question.
We have learned several ways to solve systems of equations, including Gaussian elimination, Gauss-Jordan elimination. In this section, we're going to learn yet another way to solve systems, and this is using inverses. Okay? So the way you do this is the following. You have to rewrite, so here it is, solving a system. Follow these steps. Rewrite the system in matrix form, like this. Okay, so you have a coefficient matrix times the variable matrix equals the constants matrix. And I will run you through an example. So that's the first step, is rewrite it in matrix form. Then you find A inverse, and then you multiply A inverse times B, and you get your solution. So let's do this example. First step says to write it in matrix form. So now we have matrix A here times matrix X equals matrix B. Matrix A is the coefficient matrix. So it's just the coefficients of my system, meaning 2, -3, -3, 5. Next is the variables. Okay, hang on. Next, it's the variables. So it's times the variables in a column matrix, X and Y. Okay, so that is definitely a column matrix. Next, right, it says the constants. The constants are -1 and 3. Okay? Now, do you remember, okay, so in algebra, right, when you have something like this, 3x is equal to 5, and you want to solve for x, what do? You divide by 3, but what do you really do? You multiply both sides by the inverse, by the multiplicative inverse. So you multiply this by the multiplicative inverse. That's what we're going to do now. We're going to find the inverse of this a and multiply it with this to get my answer. Okay? All right, so let's find for a, this is a. Let's find now the determinant of a. Well, that's just 5 times 2 minus -3 times -3. So that's 10 minus 9, 1. Okay? Now I need to find a inverse. A inverse is 1 over the determinant, and you need to know how to do this for tomorrow's quiz, times the A matrix rearranged basically, right? So the main diagonal changes seats, right? So these will change seats. It'll be 5 first, then 2. And the second diagonal will be positive 3s. So my A inverse then is 5, 3, 3, 2. Now, the answer, x, this is really, so x is the, the column matrix xy, right? So here's how I'm going to find x. It's going to be A inverse times B. What's the B matrix? -1 and 3. Okay? So remember, this is A and this is B. So I'm going to do A inverse times B. All right. This is a 2 by 2 and this is a 2 by 1. So the answer is going to be a 2 by 1. All right. In the first spot here, I have first row, first column. So 5 times -1 plus 3 times 3. How much is that? 4. Here I have first row, second column. No. Second row, first column. So 3 times -1 plus 2 times 3. That's -3 plus 6. That's a 3. So that's it. I've solved it. That means my XY matrix is 4 and 3. Whoops. That means my solution is 4 and 3. X is 4, Y is 3. So that's another way of doing it. I could have just done this. Huh? Okay. Yeah. Which 3? This one? How you get this one? Okay, so this is the second row, first column, right? Second row, first column. So it's 3 times -1 and 2 times 3. 3 times -1 plus 2 times 3. Right? It's like this. 3 times -1, 2 times 3. -3 plus 6. Second row, first column. Second row, first column. Okay? All right, so that was, okay, so we have Gaussian, Gauss-Jordan, solving
by inverse.
By inverses. Next, solving using Kramer's rule.
Who's Kramer?
Kramer is another mathematician. I totally agree. Yeah, Millikan method. Yeah, it's like m squared. Yeah. No. So Kramer's rule uses determinants only. Okay? So here's how we're going to do this. And again, in the beginning, when you're reading this, you might get confused, but let's do one. And then when you're doing the rest, just follow those steps. So first, you have to find the determinant of the coefficient matrix. We call that A. Then you have to create, or you have to generate, different matrices for your X, for your Y, for your Z. All right? And I'll show you how to do that. You find all of the determinants, and then you divide the determinants. It's really very, very simple. In this case, instead of X and Y, they tell you X1 and X2. It's the same thing. A lot of times, like when you get into, upper level math or the sciences, they stop using the different variables. They just pick one variable, and then it's like X1, X2, X3, X4, all the way to X10 or whatever, okay? So it's the same thing. So first I'm going to create my A matrix. This is just the coefficients. So A is 4, -5, -3, and 2. Okay? Now, next I have what I call AX1. Okay, X1 for the first variable. The way I do that is this. Now, this is the X column, and this is the X1, and this is the X2 column. For AX1, the first column gets replaced by these constants. Okay, so -49, 28. The second column is unchanged. Okay? Now I'm going to do AX2. For this one, the first column stays, and the second column gets replaced by the constants. Okay? All right. So you have your original matrix A. First, you replace the first column by the constants. Then you replace the second column by the constants. Now, we're going to find the determinants of all of these. So, determinant of A, determinant of AX1, determinant of AX2. All right, so in this case, it's 8 minus 15. So determinant of A is -7. In this case, it's -49 times 2 plus 28 times 5. So how much is that? Well, it's minus, so it's plus, right? So it's 42. Well, it's minus 28 times -5. Okay. So AX2 is 4 times 28 minus -3 times -49. So it's 4 times 28 minus 3 times 49, right? -35. All right, we're almost there. Now, to find X1, I divide AX1 determinant over determinant of A. So that's going to be 42 over -7, -6. For the other one, X2, I say AX2 determinant over determinant of A, -35 over -7, 5. So the answer then is -6, 5. That's Kramer's rule. Sometimes. I mean, it's like solving the other systems. Okay? So this is Kramer. You really don't deal too much with the matrices. It's just the determinants. Yeah. All right, let's do another one. Anything. Yeah, this is a 3 by 3 now. Next. Okay. So I'm going to find my I'm going to write my A matrix. Now, there is no x in the first equation, so it's 0. So it's 0, 1, 4, huh? Yes. And then it's 2, negative 2, 1. And then x, for the x is 1, 0, negative 4. So that's my A matrix. Next I have my AX matrix. The first column is going to get replaced by negative 1, negative 18, 7. And the rest stays the same. Now it's AY, right? So the first column stays the same. The last column stays the same. The inside column changes to negative 1, negative 18, 7. And then we have AZ. It's going to be, what? 0, 2, 1 for the first column, 1, negative 2, 0 for the second column, and it's the third column that changes to negative 1, negative 18, 7. Negative 18, 7. Okay, so now we're going to have to find the determinants of all three of these matrices. So determinant of A, right, we're going to do it with a calculator. So I'll show you very, like a quick way of doing this. All right, you go second matrix. You're going to edit the one that's already in there. All right, so you enter until you get to the first one. So let's put our matrix in there. 0, 1, 4, 2, minus 2, 1, 1, 0, minus 4, right? Enter. Don't forget to press enter that last time. Second quit. And, okay, look. Here we already found determinant of A, right? It already says determinant of A. If you just press enter, it finds determinant of A, but of the new matrix. Quick. Okay, you see how I had already found determinant of A? But for the old matrix, if I just press enter, it just finds the new one. You don't have to like re-enter.
Got it. 17.
17. So now, so that one is 17. Now for the other one, look, second matrix again, we're going to edit. So watch. Watch up here for a minute what I do. Press the right arrow until you go to the first entry. Okay, so for the first one, I'm going to do negative 1. Now press the down arrow, not enter, down arrow. Now press the down arrow again, negative 18, press the down arrow, 7. So this is a quick way of changing that matrix. And now look, I go to my home screen, press enter, and that's my new determinant. All right, so really you have to use it to your advantage. So here's what I'm going to do. Ari, what are you doing now? Find the determinant. Okay. Somebody find the determinant of AY and somebody else.
I'll do it. How do you do
I'll do AZ.
I'll do AY.
All right, so what did we get for the first one? Was it 17 or negative?
17, and then the next one's negative 17.
Okay, so here's 17. AX is negative 17. No. No. Is it 119 maybe?
AC
The
is
next one's negative
34.
34.
Yeah,
Yeah, AC is negative.
And what about AY?
That's Stephen's.
No,
0 to 1, 118.
Is it 119? Yes. Okay, so X is negative 17 over 17, 1. Y is 119 over 17, 7. Z is negative 34 over 17, negative 2. So I got 1, 7, negative 2. That's my answer. No. Okay?
so you put each one over the
Determinant. Not discriminant, by the way, determinant.
Okay. Can I see the map? Yeah, right there.
Okay. So for this one, I'm going to cheat and find negative determinant of A first. Well, because first, like for the other ones I had done, you know, the other matrices first. I'm just going to find determinant of A before I write down my other matrices. Because determinant of A is negative 36 minus negative 36, which is 0. And
It's
you
singular.
can't divide.
No solution.
Right.
Can't think of
So
the
would you
guy.
recommend doing the determinant of the first one?
Yeah. I just knew the answer, so I was working backward. So, speaking of pies, I'm doing a segue. Right. This is a tribute to Trig with
Chocolate pie.
with
I mean, there it is.
pies. It's a punny tribute to.
Strawberry pie.
No pie.
There is no 3.14 pie. Okay. So a committee is planning an event for 400 guests. The guests can choose one of the 3 options for dessert shown below. The chef spends 5 minutes on each pie, 8 minutes on each trifle, 12 minutes on each cheesecake. Now, the total cost is $11.70, and it tells you here how much each of them cost. The chef spends exactly 45 hours preparing all these pies. Use Kramer's rule to determine how many servings of each dessert were prepared. How many servings of each dessert? Now, if you have 3, you know, the pie, the trifle, and the cheesecake, we have 3 unknowns, right? The servings of the pie, the servings of the trifle, and the servings of the cheesecake. So if you have 3 unknowns, you have to be able to come up with 3 equations minimum in order to be able to solve it. If you have 3 unknowns, but can only come up with 2 equations, that means you don't have enough information. It's unsolvable. Okay? So 3 unknowns means you need 3 equations. Well, I think we can come up with 3 equations here. So you have 400 guests, right? So you need 400 of these. All right, so I'm going to call the servings of pie P, and the servings of trifle T, and the servings of cheesecake C. Okay? Now, the number of servings of the pie plus the trifle plus the cheesecake is going to equal 400. So that's your first equation. Okay? Now, how much did it cost? It cost $1,170. Well, it's $3 for the pie, $2.50 for the trifle, $4 for the cheesecake. So 3P plus 2.5T plus 4C equals 1170. Now, hours. Well, minutes rather. 5 minutes on the pie, so that's 5P. 8 minutes for the trifle, is 8t and 12c for a total of 45 hours, which translates to 2,700 minutes. Those are my three equations. And it says to use Kramer's rule, so I have to use Kramer's rule. And this is a solvable one, right? They're not going to give you a no solution one for this. Okay? So what we do is we write down the A matrix. And the A matrix is 1, 1, 1, 3, 2.5 and 4, 5, 8, and 12. And it turns out the determinant of A is equal to, so you're just going to put it in your calculator, and we did that, and we got negative 6.5, right? Yeah. Right. So you're just going to modify the matrix that's in there, blah, 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 blah. All right, now, I need a matrix for P. So my AP matrix is the first column of 400, 1170, 2,700, 1, 2.5, 8, 1, 4, 12. So here's what I'm going to do. The determinant of this one is, it turns out, negative 1,430. All right? So what does that mean? P is determinant of AP over determinant of A, negative 1,430 over negative 6.5, it is 220. So P is 220. Okay? Let's do the one for T. So what's the matrix? 1, 3, 5, 400, 1170, 2,700. Determinant of AT is what? Negative 910, right?
Yep.
Yes. So T is negative 910 over what?
Over
Negative 6.5. So I got 140 of these. Now, do I have to do this again?
Yeah.
No.
Why not?
Because 220 plus 140 minus 400 is negative, and then you just
Right. So total P plus T plus C was 400. So 220 plus 140 plus C is 400. So how many of those cheesecakes?
40.
40. So that means I got 220 pies, 140 trifle, and 40 cheesecake. Yes.
Even though we discussed tomorrow.
Yes. And tomorrow we get to do partial fractions, my favorite.